Okay, hi and welcome to Logs Lesson 4. We're going to be looking at solving equations this time that contain some sort of exponential component. We're going to do it in three different ways. The first we'll look at just using the definition of what logs are. The next we'll look at using the logarithm of a particular base. And then here we'll use a logarithm of any base. And we'll see how in each of these we can get an answer relatively straightforwardly. First of all, let's just think about what a logarithm means and how we can use it to solve this problem. First of all, the logarithm is the power that you have to raise its base to get a particular answer. Well, that's exactly what we've got here. We're trying to find the power that you have to raise some base to get a particular answer. So we can just rewrite this as the following expression. What is the power that I have to raise 2 to get 32? Well, that will be the logarithm of base 2 brackets 32. That's going to be my answer. We can either type that into a calculator or just your 2 times 2 times 2 times 2, realize x is 5. 2 to the power 5 will give us 32. We're going to do the same or similar over here, but this time let's think about log to the base 5 and how that is the inverse operation to 5 to the power of something. So if we raise both sides of the equation to, take logarithm of base 5 of both sides of the equation. Log to the base 5 of the left-hand side, log to the base 5 of the right-hand side. We can see here that we've got two inverse operations. So these two things are going to cancel. They're just going to leave us with x. But on the right-hand side, we keep all that we've got there. And now that is our answer. That's all that we have to do. Because this, a bit like a surd, is going to give us an irrational number, but we can type it into our calculator to give an approximation. The third way shows that actually you don't need to use log to the base of whatever base you're using to solve the problem. You can use log of any base. That's particularly good if, say, we don't know that that's a 5. Maybe in this case we know that's a 3. Maybe that was a y. We can still solve that or rearrange that equation even if we don't know what base that is. So what we're going to do is I'm going to use ln, logarithm base e, that irrational number that we were introduced to a little while ago. Let's take ln of both sides of this equation. So ln of the left-hand side, ln of the right-hand side. And now we're going to use our rules of logarithms, the log laws, to be able to rearrange and solve this equation. Notice here we've got logarithm of, or ln 3 to the power of something. So let's use the power rule to take that power and multiply it in the front of the logarithm. So we're going to get x minus 1 times ln of 3. The right-hand side hasn't changed. Now, we've just got a number equals another number, and we've got times by the variable that we want to find the value of. So here, let's get rid of everything other than the x. So we're going to divide both sides by ln 3, giving us this. Add 1 to both sides, and we've got our answer. Again, this is going to be an irrational number, so that is our exact answer. We could type it into a calculator to get an approximation. Ultimately, that's the crux of what you want to be able to do in exercise 7C. Have a go. You may want to watch the video a couple of times. Remember to use the examples in the textbook. Spend time reading it. Reading maths is a lot different to reading English. It might take you a minute or less than a minute to read a page of English writing, but mathematics might take you 10, 15 minutes to even read just a couple of paragraphs or lines. So take your time, and well done.